Hello students, today we will start with new topic number 3.3, average speed and average velocity. Now, according to definition of average speed, it is the total path length upon time taken. Means, suppose if any particle is moving on a path, then what is the length of this path? So we have to consider the total length that is kept in numerator, and to travel from this point A to B, what is the total time taken? So that is kept in the denominator. So it is the total path length upon time interval is nothing but it is average speed. Now students, one question arises that why it is taken as average speed and not simply a speed only. It is because when any particle or a vehicle moves from one point to another point, then its speed at each and every point is not same. It can be different also. Even when you move on a road, then also we know that at each and every time the speed changes. When there is a bump on a road, the speed decreases, and when there is a plain road, the speed increases. If there is a traffic, speed decreases. If the traffic is less or no traffic, the speed increases. So during the motion from initial position to final position, the speed does not remain constant, and so the concept of average speed is taken. Now, unit of average speed, it is same as that of speed. Distance or path length is in meter and time is in seconds. So upon time, and that's why it is per second. Average speed or simply speed is a scalar quantity, means it does not have any direction, means direction is not important for speed, and if the direction is not involved, it is always positive. Students, in our earlier topic we have studied that path length is always positive, and so speed or average speed, it is also positive. Next is about velocity. Now in our general discussion or in our general talks, we consider speed or the velocity as same thing. But students, in velocity the direction is also involved, and so according to definition, average velocity is given by displacement upon time taken. We have seen that in average speed it was the total path length, but here in velocity it is displacement upon time. and whenever the displacement is considered, we have to use the final position minus initial position. And so here also final time minus initial time. Now students, once again I'll give you this example. Suppose if any particle is moving from this point A to point B. So in this case, if we consider this whole path along which the particle moved, and if we consider that length of the path, then that is considered as a path length, and path length upon time taken is average speed. But here for average velocity we have to simply consider the straight line between the points A and B, and this distance is to be considered. So here displacement is considered as the distance between A and B, and also the direction with it. And so velocity is displacement upon time. Now unit displacement is in meter and time is in second. So meter per second, same as that of average speed. Now path length was scalar quantity because it does not have any direction. But here this average velocity, it has a direction involved in it, and so it is a vector quantity. And any quantity which is involved with direction, it can be positive, negative or zero. We have also seen and studied in earlier topic that displacement can be positive, negative or zero, and so the velocity. Now once again, why we are not simply considering this as velocity and we have to use the word average velocity? The once again reason is same as that in the case of average speed, because when any vehicle moves on a path, every time at different time intervals the velocity or the speed is different. And so when we have to consider the entire path along which the particle or a vehicle moves, then it is considered to be average speed or the average velocity. So students, always remember that when there is a velocity, direction is involved, and if the speed is there, then in that the direction is not involved. Now students, we know that when we define velocity, there is a displacement upon time. So now representing this velocity in terms of graph for uniform motion, if we draw the position time graph, then we will get a straight line, and if the straight line is there, then the motion is considered uniform motion. That means at any time interval the velocity remains constant. So if the velocity remains constant, we can say that the motion is a uniform motion. So whenever in a position time graph, if there is a straight line, then we have to consider that motion as a uniform motion. Even you can see that in this graph also, the line is straight only. Even in next figure also, the line is straight only. So in all these three cases, the motion is uniform. But there is some difference. Now what difference is that? So students, suppose if the particle starts its motion, and suppose if we consider its motion at time t is equal to 0, and then with increase in the time, the position also changes. Here x shows the position in meter and time is in second. So now it is clear from the figure that after 1 second, the particle is reached at 5 meter from the origin. Then after 3 seconds, the particle is reached at 15 meter on a straight path. So if we want to find what is the velocity or the average velocity in this case, so we have to consider two different time intervals. So here the first time if we consider 1 second, and the other time if we consider 3rd second, then what is the difference in the time? So difference in the time is delta t, that is final time minus initial. So 3 minus 1 will give you 2 second. And what is the position change for this time? So initially the position was 5 at 1 second, and then after 3 seconds the position is 15. So here this is the final position at 3rd second, and this is the initial position at 1st second. So difference in this position can be taken as final minus initial, and so 15 minus 5 is 10. So it is 10 meter. So we can find the average velocity as like this, that average velocity v is nothing but it is the slope of the graph. You can see here that we have obtained the slope. Delta x upon delta t will give you the slope of this straight line, and so here this slope will give us the average velocity. So delta x upon delta t means displacement upon time interval. What is delta x? So that is 10. And what is delta t? It was 2. And so 10 by 2 is 5 meter per second. So we obtained slope as 5 meter per second, and that is nothing but the average velocity. Now students, you know that here we have considered these 2 points for the slope. But if you consider any 2 points of the slope, then also you will get the same result, because for a straight line the slope remains constant. For example, if we have considered the initial time as 0 second and final time as 1 second, so what is the position at 0 second? So it is 0 meter. And what is the position at 1 second? It is 5 meter. So what is difference here for delta x from here to 0 to 5? It is 5 meter. And what is difference of time from 0 to 1? It is 1 second. So 5 upon 1, again the answer is 5 meter per second. So students, the answer will be always same for the slope, and that will give you the average velocity. If you will consider this as the final position and again this as the initial, then also this time is 3 seconds, and this much displacement delta x will be 15. You can see here this much distance is 15. So 15 by 3, again the result is 5. So whenever there is a straight line, the slope remains same for this position time graph, and that slope will give you the average velocity, and it is positive in this case because the result obtained is plus 5. So students, always remember, for the upward slope like this, the velocity will be positive. Now in the next case, you can see the slope is downward, and for this type of downward slope it will be negative. Now once again, let us consider the 2 points on this downward slope. We have considered this point and this point. You can take any 2 points to find the slope. Not necessary that you have to choose this and this only. So now if we are considering these 2 points, then the initial time is 2 here and the final time is 6. So what is difference of time? So final minus initial. So 6 minus 2 will be 4. 4 second is your delta t, that is difference in the time. And for difference in position, we'll consider final position which is at final time and initial position which is at initial time. So this is the initial position and this is the final, and so if we'll take the difference, final minus initial, so 10 minus 30 will give you minus 20. So what is our delta x? Delta x is minus 20 and delta t was 4. So now using this in this formula, average velocity is the slope of the line, and that is delta x upon delta t, but delta x is final position minus initial, delta t is final time minus initial time, and the result obtained is 5. Why? Because in this numerator it is minus 20 and in this denominator the difference is 4. So 4 ones are and 4 5s are. So result is negative minus 5 meter per second. So students, always remember, if the slope is downward, then it will give you negative. Now if the slope is neither upward nor downward, means the line will be horizontal. So here you can see that the line is horizontal. Now here initially suppose the time is 0, at that time what is the position? It is 4 meter. After 5 seconds, once again what is the position? 4 meter. After 10 seconds also, what is the position of this particle? It is 4 only. So at every time we'll find that as the line is horizontal, the position will remain same. And if the position is same, the particle is considered stationary, and stationary particle has zero velocity. So here in this case the velocity will be 0 because there is no slope, because the slope gives us the velocity, and as the line is horizontal means it does not have any slope, and no slope means it is 0. So velocity is 0 meter per second. So students, I hope you understood this. So once again we will do a quick revision. If the slope is upward, the velocity will be positive. If the slope is downward, velocity will be negative. And if there is no slope, means if the line is horizontal, then in that case the velocity is 0. So velocity can be positive, negative, or 0. So this is about the position time graph for uniform motion. Velocity remains constant and the graph will be linear graph, straight line graph. Now next is about non-uniform motion. Now we know that students, if the motion is uniform, then the graph will be straight line, and if the graph is not a straight line, then that will be non-uniform motion. So here also you can see that the graph is a curved graph, it is not a straight line. So here this is an example of a non-uniform motion. Now whenever there is a non-uniform motion, the velocity does not remain constant. So remember, v is not constant for this type of graph. Here a position time graph is shown. This shows position x, which is in meter, and this line shows time, which is in second. So now in this case, if you will find the average velocity between any two time intervals, then that velocity will be different. Suppose if we'll consider the velocity between time t is equal to 0 second to time t is equal to 1 second, then at that time the velocity will be different. From 1 second to 3 second also the velocity will be different, because there is a curvature here. Again from 3 to 5 second or 6 second, you can see the graph is once again curved only, so the slope changes every time, and so velocity does not remain constant. So now to find average velocity in such case, we have to use the similar formula, that is delta x upon delta t. Let here the initial time is 3 second and the final time is 6 second. So what is delta t? So it is final minus initial. So you will get 6 minus 3, that is equal to 3 only. So difference of the time is 3. Now what is delta x here in this case? So this is the final position at time t is equal to 6 seconds, and this is the initial position which will be 5 at time t is equal to 3 seconds. So now difference of this final position and initial position, that is 20 minus 5 will give you 15. So 15 divided by 3 will give you 5. So this is about the non-uniform motion, and you can get the average velocity for two given times. If you'll find the average velocity for time t is equal to 0 second to time t is equal to 3 second, then for that also average velocity will be different and not the same. Why? Because the line is not straight, it is a curved line. So for every time interval, every different time intervals, the velocity will be different. Now students, example number 3.1. So here for this example, you have to consider figure number 3.1 given on page number 40. So here we have to find the average velocity as well as average speed for path OP first, and then for path OPQ. So if we consider this figure which is given on page number 40, you can see that for this path O to P, if you want to find the displacement, then it is how much from here to here? Definitely starting from 0 to it is 360. So displacement will be 360, and for that the time taken, that is given. How much time taken? So it is given in the statement for this path OP, the time taken is 18 seconds. So divided by 18. So if you will divide this 360 by 18, then you will get result 20. So what is the average velocity? It is 20. Now this 20 will be positive. Why? Because the particle moves from O to P towards the positive x direction, and so the average velocity will be positive. Now about average speed for the same path, as it is along the straight line. Once again, path length is 360 only, and again the time interval is same, that is 18. So result will be 20, and we know that the speed is always positive because path length is always positive. So here we will not use the word plus or minus sign for speed, but whenever there is a velocity we should mention positive or negative. Here it was positive for average velocity. So students, first part, that is for path OP, it is clear. Now for path OP and then again Q. So for this total path we have to find again the average velocity and the average speed. So students, now look here in this figure, if the particle is moving from O to P first and then from P to Q, that is this position. So for average velocity, what we use? We use displacement upon time taken. So what is the displacement here? So final position was Q and initial is O. So final minus initial. Final is 240, initial is 0. So 240 minus 0 will give you 240 upon time. Now here the time taken for P to Q is 6 seconds given in your textbook, you can see. But for this O to P, the time was 18 seconds. So 18 plus 6 will give you 24. So difference in the time for this whole path, that is OPQ, is this much. So if you divide this, you will get 10. So average velocity will be 10 meter per second. Once again, you can see initial to final, it is towards the positive x direction. So this average velocity will be plus 10 meter per second. Now about average speed. Now for speed, we know that entire path is to be considered. That is from O to P, that is 360. Then from P to Q, how much it is? It is this much. And that difference is, you can say here, that 40 plus 40 plus 40, that is this much difference is 120. So 360 plus 120, and that is nothing but 480. So what is entire path length? It is 480, and time is once again from O to P it was 18, from P to Q it was 6 seconds. So 18 plus 6, it is 24. And so now if you will divide this, the result will be 20, because 24 twos are 48 and this 0, so 20. So path length upon time gives you average speed, and it is always positive. So students, in this example I have solved this. You can see for path OP, the average velocity is plus 20 meter per second and average speed is 20 meter per second. For path OPQ, the average velocity is plus 10 meter per second and average speed is 20 meter per second.